Hi everyone and welcome back to Mossymaths GCSE. Today we're going to be going through a lesson looking at ratios. And ratios is a topic that links very closely with fractions. And I'm going to show you in this lesson how that works. Now the way to think of ratios at GCSE level is like a pizza. We could have X amount of slices and each slice represents a part of the ratio. For example, if we have 10 slices of pizza, I could share that out equally between 2 people, giving each person 5 slices. That would be the ratio 5 to 5. In other words, each person gets 5 parts of the ratio, 5 slices. Or I could share that unequally between 2 people. I get 7 whereas someone gets 3 slices. Then the ratio will be 7 to 3 in favour of me. But I could also split that between 3 people. 2 to 5 to 3, for example. I get 2, someone gets 5 and someone gets 3 slices. And so a ratio is just a way of showing how we share different parts of something. So the key points are going to show how that works. Red, purple and orange beads shared in the ratio 4 to 3 to 3. And you can see this with the diagram. 4 red, 3 purple and 3 orange. Now the order we write the words corresponds to the order that the ratio is written in. So that's something important that we should know. Simplifying ratios is very similar to simplifying fractions. In a fraction, we'd have to do the same to the numerator as we would the denominator. And it's similar here. We just do the same to the left-hand side as we would to the right-hand side, or to each part of the ratio. So for example, if we have 5 to 10, well, we should know that 5 goes into both 5 and 10. 5 goes into 5 once, and 5 goes into 10 twice. So we have the ratio 1 to 2, dividing both sides by 5. The second ratio, 6 to 1.5, well, to get rid of the decimal, we then multiply both sides by 2, giving us 12 to 3, and then 3 goes into both of them, so we divide both sides by 3 to give us 4 to 1. So here we've had to do numerous operations to get to the simplified ratio. Ratios as a fraction, well, the way this works is we can convert it by finding out the total number of parts. So if we have the ratio 2 to 3, then we have a total of 5 parts. We have a total of 2 plus 3 parts. Now the 5 is a total number of bits, and so that's the denominator of our fraction. So we could have 2/5 and 3/5 all together, depending on which side of the ratio we look at. To demonstrate this, we have an example. 50 sweets are shared in the ratio 3 to 2 between Tom and Matt. So the order we've written this corresponds to the parts of each ratio. So Tom gets 3 parts and Matt gets 2 parts of the ratio. How many did Tom and Matt get? So, we first of all find out the denominator of our fraction, the bottom of it, which is the total number of parts of the ratio, 3 plus 2, which is 5. Now what we do is we divide the total number of items, in this case sweets, by the total number of parts of the ratio to give us how much each part of the ratio is worth in terms of sweets. So 50 divided by 5 gives us 10. So one part of the ratio is 10 sweets. Therefore, if we look at Tom's share, which is 3 parts of the ratio, then this is simply just 10 times 3. That gives us Tom's share. If one part of the ratio is 10, then 3 parts of the ratio is 30. So Tom gets 30 sweets. If Matt's share is 2 parts of the ratio, then Matt gets 2 times 10, 20 sweets. So Tom gets 30 and Matt gets 20. So that's how it works with a ratio. Just look back over that if you're not entirely sure how that works. Now, with the examples we're going to go through, these are a mixture of exam style questions and just kind of pointers to give us an idea of how we should approach ratio questions. The first one says simplify a half to 3/4 as a ratio. Now of course we don't want a fraction, so we have to eliminate the fraction. What can we do to both sides? Well, we should notice that a common denominator is 4. So if we multiply both sides by 4, we're going to get whole numbers. So multiplying by 4 gives us 2 on the left hand side, a half times 4 is 2. And on the right hand side it gets rid of our denominator to give us 3. So that is the simplified version. The second one, 25 millimetres to 5 centimetres. Well, with this question, the way we simplify it is simply by converting them into one unit. So, for example, we could convert both to centimetres or both to millimetres. I'm going to go for millimetres. So if we leave the left-hand side as 25 millimetres, then the right-hand side is going to be 50 millimetres. Of course, 5 centimetres is 50 millimetres. We can simplify this though. 25 goes into both sides, so if we divide both sides by 25, we end up with 1 to 2 as our simplified ratio. To make pink paint, red and white paint can be mixed in the ratio 1 to 2. to make 4 litres, how much red and white paint is needed. So we're making pink paint. The important part is that the ratio is between the red and white paint in the ratio 1 to 2. So the left hand side is the red, because that's written first, and the right hand side is the white paint. And we're making a total number of 4 litres. Well, first of all, let's work out the total amount of parts of the ratio. So that is our denominator of our fraction. And similar to what we did here, we're dividing our total number of items, in this case it's in litres, by our number of parts. So we're doing 4 divided by 3. Okay? And this is giving us 1 part of the ratio. Therefore, if our red paint is 1 part of the ratio, then we have 4/3 litres. If our white paint, however, is 2 parts of the ratio, we have 2 times 4/3 litres. In other words, we have 8/3 litres of paint. Boys and girls are divided into teams in the ratio 3 to 4. There are 8 girls in one team. How many boys are in the teams? Slightly different here. We're not working out the total number of parts of the ratio. The items that we're given is the amount of girls, which is the second part of the ratio, the 4 part. We're not given the total number of items. Therefore, we're given 4 parts of the ratio. We're given the amount of girls. So to work out 1 part of the ratio, we simply do the total number of items divided by the amount that corresponds to that, which is 4. So 1 part of the ratio is 2 people. Okay? Because, as I said, 3 to 4 is the amount of boys to girls. So if we're given the amount of girls, we're given this part of the ratio, which is 4. So to find 1 part of the ratio, we divide 8 by 4, which gives us 2. So to work out the amount of boys, we simply multiply 1 part of the ratio by the amount of parts of the ratio that corresponds to the boys, which is 3. So we've got 6 boys in the team. And finally, a map is drawn using the scale factor 2 centimetres equals 3.5 kilometres, and the distance between Manchester and Oldham is 8.5 kilometres. What will be the distance on the map? Okay, so we're given the amount of distance in kilometres. So we're given this part of the ratio, because effectively this is a ratio here. We have 2 centimetres equals 3.5 kilometres. So we have 2 to 3.5. And we're given the 3.5 part. So if we do 8.5 divided by 3.5, that gives us 2.4285. Sorry, that gives us 2.42857 and some more numbers. Now that gives us 1 part of the ratio, because we've simply divided our total kilometres by the amount of kilometres here. Don't be put off by the equals sign, because in this case we can just replace that with a ratio symbol. Okay, because effectively we've got a scale factor here. So 1 part of the ratio is this, and 2 parts of the ratio will give us the amount that is represented in centimetres on the map. So we simply multiply this answer by 2, multiply it by 2, and we get 4.86 to 3 significant figures, centimetres. Okay? So that covers the topic of ratios. Thanks a lot for watching the video. If you found it helpful, then please do leave a like. If you have any comments, then leave that down in the comments section. So thanks a lot, and I'll see you in the next video.